In this lecture we will take a look at how data can be stored on the grid. One of the things that we will see is that in a grid environment data files can be replicated, possibly on a temporary basis, to many different sites depending on where the data is needed. The users or applications do not need to know where the data is physically located. They use logical file names for the files. Data management services are responsible for locating and accessing the data. Data on the grid is stored on so-called storage elements or SEs. The data on the storage element is stored per VO, and only users of the same VO have access to the data. Do keep in mind that all users of a particular VO have access to the data and that there is no finer grained control like you would for example have in Unix systems. So it's on a VO basis. Grid jobs need to access files located on other machines. We have already seen the in and output sandboxes as ways of transferring data to and from the worker nodes. We have also shown that the amount of data that can be transferred like this is relatively limited. It can also be inconvenient to send files back and forth all the time in a network connection on a workstation that is not very fast. Normally the files needed for a job are stored on grid storage resources. The Logical File Catalog, or LFC, provides a virtual interface to other distributed storage systems. In this manner, the files receive intuitive names. They can be stored in several grid sites or replicated and still be manipulated easily from the command line or even the graphical user interface. The Storage Resource Manager has been designed to be a single interface for the management of disk and tape storage resources. So the SRM is the protocol that governs the SEs. And the SRM hides the complexity of the resources set up behind it and allows the user to request files, keep them on a disk buffer and stored for a specific lifetime, or reserve in advance the disk space needed for new files, and so on. It is important to notice that the SRM protocol is a storage management protocol and not a file access protocol. This also means that there are multiple implementations of this protocol, where each implementation is good under particular circumstances. The three major implementations are dcache, dpm and storm. And for all the sites this choice has already been made for you, so unless you're a grid administrator there's no real need to make a decision on which one to use. The storage element is a service which allows a user or an application to store data for future retrieval. The Gsi Ftp Protocol offers the functionalities of FTP with support for the grid service interface. It is responsible for secure file transfers to and from storage elements. It also provides third-party control of data transfers as well as parallel data stream transfer. And every SE runs at least one grid FTP server. Also keep in mind that these third-party transfers are actually quite important. What this means is that you as a user can request one SRM to transfer data to another SRM without actually having the data transferred to you first. So the data does not need to pass your workstation to be moved from one site to the next. This is one of the powerful features of the SRM specification. Each cluster on the grid is equipped with a storage element or SE where the data is stored. On which SEs you can store data depends on your virtual organization, and this can be inspected by the command that we've shown before, the LCG info sites, using the SE flag to specify that you want a list of all the storage elements that are available to your virtual organization. Sometimes it's useful to store your data on more than one SE. This is called replication. This allows jobs to run close to where the data is located, which reduces the long-range network traffic. SEs identify files by storage URLs or SURLs, and these identifiers are not very descriptive. So one example is the one that we see here, where it's just a file with a particular number and located in a folder which is just a date. So the Logical File Catalog allows you to give more descriptive names to your files and to order your files in a directory structure. Bear in mind that the LFC is not itself a storage system, it's just a database that keeps track of the files, so just think of it as a metadata store for file names. What we see here is the normal way of submitting files to the grid using the CE and then using the storage element to store and then retrieve from the data that we are going to process. The process will then write back the data that was generated to the storage element, and it's retrieved by the user that can then inspect that output. So what we see here is the data transfer from the user to an SE, and then the central SE, and then a replication taking place between the centralized storage element and the storage element for one cluster. And this can be handy because you want to have the data located to the worker nodes that are going to compute. So when the user fires a job, the worker node will fetch the data from the nearest location, transfer the output to the local SE, and then transfer it back to the centralized one, and finally the user can retrieve that data. So this is the normal worker node, or this is the normal way in which you would use replication to work with worker nodes for a particular site. And of course it depends on the amount of data that you need to transfer and the intermediate internet connections that you have available on how this replication should take place. So you can manipulate your data with a set of command line tools, and some of these commands start with LFC, which stands for Logical File Name Catalog, while others start with LCG, which can be confusing at first. All the LCG type of commands operate on the data itself. Additionally, some of these commands have side effects in the LFC. For example, the LCG-CR command uploads a file to the SE and registers these files in the LFC under a certain name. So this command really does two things. It is taking care of the data transfer from wherever the data is located to the storage element, and once that's completed, it registers the file in the logical file name catalog and make the link between them. The LFC commands only operate on the LFC and don't manipulate the data. For example, the command LFC make there creates a new directory in the LFC, but this has no real impact on the SE itself.